Hi everyone, we are Group 23 and our project topic is Toxic Comment Classification on Online Platforms. In this presentation, we will go over the motivation for this project, our experiments, and results for model comparisons. We also explored wild data from popular social medias and found adversarial vulnerabilities in the models. Every day, more users are joining social medias and interacting online. Human moderation may not be enough to keep conversations non-toxic and safe for people to discuss their opinions. These detection models can help, flagging potentially toxic comments and removing the messages themselves. In the future, it's hopeful that these models can be used to protect people and facilitate safe online interactions. This project was also inspired by Toxic Comment Classification Challenge from Kaggle, hosted by Conversation AI. The dataset contains about 230,000 comments from Wikipedia, and 8% of them were annotated by people as toxic. The comments were given a score from 0 to 1, representing the proportion of people who consider the comment toxic. As we learned from the course, machine learning models often struggle with the bias problems. This toxic classification challenge is no exception. Since some identities in the data were frequently attacked, the models incorrectly learned to associate certain identities with toxicity. The dataset from Kaggle was also labeled with identities each comment mentioned. The metric we used took into consideration how well we classified non-toxic versus toxic comments, and it also considered how likely the model was to make mistakes on comments mentioning identities. Here is the final results of our model performances. Among non-neural networks, logistic regression achieved the best result. And while decision trees had decent accuracy, it struggled with the bias problems. Not surprisingly, BERT achieved the best performance among all the models, and we showed that BERT can improve the performance of plain CNN. To improve our models, we tried undersampling non-toxic data to reduce the system's inclination towards predicting everything as non-toxic. We also used embeddings learned through the training process versus using pre-trained and frozen. Finally, we used BERT as a feature extractor as input for the CNN. We averaged embeddings from the 11th layer to form a sentence embedding and created a 2D matrix words versus embedding for the input. This combination improved the performance of plain CNN. We generated embedding vectors by averaging the output from the 11th layer of BERT. The embeddings were further reduced with PCA and visualized through TSNE. We can see a noticeable difference in the embeddings. As mentioned, one of the biggest motivations for detecting toxic comments is using it to moderate social medias. Using the BERT model, we evaluated a small dataset extracted from Reddit. Specifically, we looked at 4 different subgroups with varying popularity, discussion topics, and moderation rules. From each group, we extracted all the comments from the top 10 trending posts. In doing so, we wanted to see if there were general trends. For example, how does the group topic or number of members affect the portion of toxic comments? We also saw that every group had some rule against toxicity or rudeness. We evaluated how active the moderators were by seeing how many comments they had removed. From the results, we saw that only 6.7% of Ask Reddit comments and 5.4% of Change My View comments had a toxicity score of 0.5 or higher. The percentages were similar for the other two groups, with 9.2% for politics and 4% for wholesome memes. Looking at all the groups, we saw toxic tweets were skewed towards having ratings of 0.9 or higher. After sampling some of the comments evaluated by the model, we found some potential flaws. For example, the model had incorrectly identified several comments as highly toxic if they included curse words. The model also does not consider the context of the comments. For example, in one post where users were sharing stories of childhood abuse, many comments were flagged as toxic even if they were clearly non-toxic. Similarly, we ran the same model on COVID-19 related tweets using the tags to restrict the comments. Out of 1.4 million tweets, less than 3% were classified as toxic. For this analysis, we randomly sampled 5,000 toxic tweets and 5,000 non-toxic tweets. We used TextBlob to get polarity and subjectivity scores. From the heat map and distribution plots, we discovered toxicity is negatively correlated with polarity, but it's positively correlated with subjectivity. This suggests toxic tweets tend to be more personal and have a higher negative polarity. We also extracted the top 10 trending unigrams using term frequency inverse document frequency to reflect how important a word is in toxic tweets. Most of the phrases from unigrams or bargrams aren't surprising, but interestingly, when using trigrams and fourgrams, we were able to see more mentions of the word gay than we expected. Further reading of why this result could have occurred is linked in our references. As a way to visualize these toxic tweets, here's a word cloud of frequent words. To find other limitations of these models and demonstrate how non-trivial this task is, we planted adversarial tasks to examine false positives and false negatives. We used examples that are non-ambiguous to human users but confusing for the Perspective API, a toxicity detection API by Google. There were many false positives. Words like gay, black, or feminist can give the comment a high toxic percentage irrespective of the actual text. Colloquial, harmless phrases were also flagged just because they contained abusive words. There were also false negatives. Violence inciting comments are surprisingly detected as non-toxic. Adding a simple hyphen or dot between words can make the comment non-toxic. Content moderation is crucial as online abusive comments often discourage users from freely sharing their opinions. In this project, we hope to build a technology that will protect people in online interactions. Thank you.